Hi everyone. Today we'll be discussing the LeetCode problem of the day, delete nodes from linked list present in array. So here you are given an array of integer nums and head of a linked list. You just have to return the head of the modified linked list after removing all the nodes from the linked list that have a value exists in the nums. So you're given an array nums in which all these elements should not be present in the linked list. So if you see the first example, you have the linked list like this: 1, 2, 3, 4, and 5. And in this linked list, from this numbers array, we can see that 1, 2, 3 should be deleted. So we have to remove all the occurrences of 1, 2, 3. And whatever the linked list remains, we have to return this. So the output will be 4 and 5. So you just have to return the head, which is pointing to 4 of this linked list. And in the second input, we have linked list as 1, 2, 1, 2, 1, 2. So in this linked list, we in the numbers array we have 1. So we have to remove all the occurrences of 1. So when we do that, he mentioned that in red. So the modified linked list will contain only the 2's. So the output will be 2. That means you will return a linked list with head pointing to 2, and this is the remaining linked list without these ones. And finally, we have the third input. The linked list is 1, 2, 3, 4, and the excluded number should be 5. Deleted number should be 5. And since in this linked list we don't have number 5, so we just return the linked list as it is. So we just return the head as 1, and this is the linked list which follows. In the constraints, we have the numbers array length up to 10 power 5, and each element can be up to 10 power 5. And all the elements in numbers array are unique, so they won't repeat. But in the linked list, the numbers can repeat. Like we saw here, the number 2 is repeating. And the number of nodes given in the list is in range 1 to 10 power 5. Like this is for the linked list. And in the linked list, the node dot the value again is from 1 to 10 power 5. And the input is generated such a way that there is at least one node in the linked list that has a value not present in nums. So by this, he's trying to say that at the end of all the operations, at least one node in the linked list will be not deleted, so that your linked list will entirely be not empty. Now let's go over the approach. So we just have to iterate on the linked list and delete whatever the nodes are present in the numbers array. So to access them quickly, we can first add all of these numbers in a hash set and then start iterating on the linked list. And whenever the current value is present in the hash set, just delete the value. So we just have to see how we can delete the nodes in the linked list. So for deleting, we have two types. So first is deleting the head. So suppose this is your linked list 1, 2, 3, 4, 5, and you have the input array 1, 3, maybe 4. So you have to delete first node and the fourth node. So the resultant should be 2, 3, 5. So let's see how we can do this. So first you will set current equal to head. So current is pointing to the head and previous equal to null. And you will start iterating while current is not equal to null, because at each step you will keep increasing. You'll do current equal to current not next. So that's how the current keeps moving forward in the linked list. And at some point, this will be null, and there you will stop. So you're at the current, which is at node 1, and you see that 1 is present in the hash set. So you have to delete this number 1. Now you have a case where the number you want to delete is the head. So in that case, all you have to do is set head equal to head dot next. So by doing this, you are pointing, you are changing head from node 1 to node 2. So head now currently points to this value. So by this, what we have done is, when you return the head, so this is your existing linked list. So the one is excluded. So deleting is easy when you're deleting the head. So you just have to move the head to the next number. So now head moves here, and we have deleted one, and also current moves forward after each iteration. So current is here. Now uh, so far previous is null because we have not updated it yet. Now we are at the node value 2. So we'll just check if the node value is this 2 is present in the hash set. So it's not present, so we don't delete it. So before moving current forward, we will update previous equal to current. So that means before I move current to forward, I'll set previous equal to current. So my previous is pointing to 2 and current is pointing to 3. And now again, I'm at 3. So I'll check if 3 is present in the hash set. It's not present, so we should not delete 3 as well. And again, same thing. We will set previous equal to current, and then we will move current forward. Okay. Yeah. So at this step, we can see that current is at 4 and previous equal to 3. And 4 is present in the hash set. That means we have to delete the current value. So we'll first check if the current value is head or not. So current is 4 and head is 2. So it's not a head. So once we know it's not a head, now to delete this value 4, all we have to do is, since 3 is pointing to 4, and if we delete this 4, then 3 should point to 5. So all you have to do is, we have to remove this link and add a new link to 5, and that's it. So by doing that, the linked list will be 2, 3, and after 3 we'll reach directly 5. So that means 4 is deleted. And to do this, we can just say previous dot next equal to current dot next. So that's why we keep a track of previous, because if you want to delete the current node, we need to know the previous node. So previous dot next equal to current node will update this node, this link, and form a new link like this. And after doing this, again, current moves forward, but this time we won't update the previous, because previous should remain at 3 only. Because we have deleted 4, so current is at 5, and the previous number of 5 is 3 only. So previous remains there. So these are the two conditions when you have to delete. So if it's the head, you have to just move the head forward, and if it's not a head, you just update. You just update this link. So previous dot next equal to current dot next. So by doing this, you have successfully deleted the current node. Now let's quickly code the approach. So first we'll create a asset to store all the numbers in it. Just iterate on the array. So once the hash set is done, we'll just start iterating on the linked list. So for that, we need to create a current node, and initially it will point to head. And we'll also take a previous node, and initially this will point to null. And we'll run the loop while current is not equal to null. So this means in this diagram, initially current is here, and this loop runs until current reaches null, and it stops. And head is here, and so currently previous is at null. So first we have to check if hasset dot contains current dot value. So if it contains the value, we have to delete this node. And if it doesn't contain the value, then we don't need to delete the node. In that case, let's just write the case that it doesn't contain the node. So like we discussed, we just have to set previous equal to current and move current forward. Current equal to current dot next. So this is the case where we don't have to delete it. So now let's see the case where we have to delete it. So by deleting, like we have discussed two cases. First case is if the value, the node I have to delete is equal to head itself. So in this case, all you have to do is do head equal to head dot next. So in our example, we have to delete 1. So all we do is point head to the next number. So head becomes 2. And after that, we move current equal to current dot next. So this step is common in this entire loop. So I'll just write it outside the if else case. So after even if you delete or you don't delete, you have to move the current forward. So I'm just writing it outside to avoid repetitions. So if current is head, you just move the head forward. And else in the sense, else means you will delete some other node which is not a head. So let's see that. So after this, you move the current. Yeah, after this current is here. Now you see 2, you don't have to delete 2. So it goes to the else case and it will set previous equal to current and current equal to current dot next. So current will be at 3. And again, in the next iteration, HS doesn't contain 3 also. So previous equal to current and current equal to next. So previous will be at this 3 and current will be at 4. So now we arrived the case where this 4 is present in the hash set. So we have to delete this 4. So we enter this if condition, hs dot contains 4. So current, we first check if the current value is head. So it's not a head. So to delete it, like we discussed, we have to update this link. This 3 should point to 5 so that 4 will get deleted. For that, we can just say previous dot next equal to current dot next. So by doing this, the current value is deleted. And after this, we should not update the previous value. So I'm not writing that. So this is done. And we move current equal to current dot next. So that means now current will be at 5. So this link has changed. Now 5 is again not in this in this list in the hash set. So we set previous equal to current and current equal to null. I mean current equal to current dot next. So previous is here and finally current is null. So we'll see in the while loop condition current is not equal to null. So the while loop breaks and then we'll just return head. So when we return head, so this is our linked list so far. First you're at 2, then 2 to 3. After 3, you directly jump to 5 and then null. So 2, 3, 5 is your linked list. And from that, you have successfully deleted the 1 and 4. Let me test it. Yeah, it works. Finally, let's do the time and space complexity analysis. So for the time complexity, first we are iterating on the numbers, okay, which is order of n. And after that, we are iterating on the linked list. So total time complexity, we can say order of n. plus n. Here n denotes the length of the numbers array, and the small n denotes the number of the linked list length. And for space complexity, it will be order of n, because we are creating a hash set and we are adding all the numbers from the nums array. I also have the code in Python if anyone wants to view it. I'll add it in the description as well. Let's catch up in the next video.